Hello, geometry friends. We are on lesson 5 of our circles unit number 7. And today I'm going to be showing you some more new vocabulary and some more new rules about arcs, angles, lengths, and segments in a circle. So let's start off with remembering what you're already supposed to know. So if you would please be so kind as to pause the video, name all the different parts that are asked for here in the first top half of your page, and then we can continue on with some new vocabulary. So pause, try to find everything that's listed here, and then come back and we'll see how you did. There are 4 radii drawn in. Letters can be in either order, O to C or CO, it's fine. There are 2 diameters there, shown in the graph, CY and HG. Find a right angle. The right angle comes from Thales' theorem. An inscribed angle that intercepts the diameter is a right angle, so that's angle CIY. 4 central angles. The central angles have the vertex at the center of the circle. So your middle letter should be O for your central angle because O is the center of the circle. It also is the midpoint of the diameter. So it is both a midpoint and a point and the name of the circle. The inscribed angles are the angles that have the vertex on the circle itself. We named one of them already, CIY, but we also have IYC and ICY. 2 rays that touch the circle O exactly once. 2 rays that only touch the circle once. That's what our tangent lines do, but it's a ray because it has an arrow only at one end, not at both ends. That's the difference between a ray, a line, and a segment. Segment has 2 endpoints, a ray has 1 endpoint, and a line does not have any endpoints because it never ends. And a segment that intersects the circle in 2 points. That almost sounds like I'm describing a chord, so you could have put any one of the chords as the answer to this. But what I was looking at is MG. Notice how M is outside the circle, crashes and intersects the circle, keeps going, and also intersects the circle again twice. So it is not a chord. HG would be the chord, but MG is a chord that extends past the circle. That has a different name. Okay, so let's look at these 2 groupings of segments. What's true about all the segments in group 1? All the segments in group 1 touch the circle only once. These are all tangent lines. So a tangent line is a line, segment, or ray with exactly 1 point of intersection with the circle. Tangent touches once. Tangent lines touch once. So a line, segment, or ray with exactly 1 point of intersection with a circle is called a tangent line. That's group 1. Things that we've talked about that go along with this: when a tangent line meets a radius, remember that it does so at a right angle. We did that towards the beginning of this unit when we were writing the equation of the tangent lines. When a tangent line meets a radius or a diameter, it does so at a 90 degree. Every tangent line is going to be perpendicular to the radius or the diameter at the point of tangency. Now let's look at this other group here. Group 2 is a little different. It looks like each one of these segments is a chord that has been extended beyond and goes outside of the circle. So it's a chord that extends outside the circle, a chord that extends outside the circle. This one's a chord that extends outside in both directions. Those are called secant lines. They're lines that intersect the circle twice. Line, segment, or ray that intersect the circle twice. So it's a line, segment, or a ray with exactly 2 points of intersection with a circle. But the difference between a chord and a secant is a secant has to be extended, has to have part of it outside the circle. Okay, that's called a secant versus a tangent line. There's a secant line. Tangent line touches once, secant line slices through. All right, so for the next thing, you need your compass and a straight edge. So pause the video, go get your compass. If you have a compass, you need a compass. You're supposed to have a compass. Hopefully you have one, and hopefully you have it now and I can stop babbling about it. Use a compass and straight edge to construct the line perpendicular to the tangent line at the point of tangency. So we're going to do a construction of our line perpendicular to the tangent line, but passing through. There we go. I have to unlock my compass. Sorry, my compass was frozen. All right. So in order to make a line perpendicular to the given line, but passing through that specific point, put your needle on the point of tangency. You can open your compass to any setting. Just make sure it's big enough that it will be able to intersect the line, the tangent line on both sides. You have just created 2 points that are equidistant from the point of tangency. Now do the perpendicular bisector of those 2 points. I'm going to put my needle here. I have to open my compass a little bit more than what it already was. Mark an arc. And this arc has to be marked on both sides. And now do the same thing from the other point of intersection that you created. Now I don't need the full half a circle. I just need to know where the 2 arcs will intersect. From there, I can line up my straight edge once I unlock it. I can line up my straight edge from one arc intersection point to the other arc intersection point. And then I can draw my segment. So let me get a nice fun color, lime green. So as I was saying on the previous page, radius drawn to the point of tangency will be perpendicular to the tangent line. So what kind of segment did we create? Well, we just created a radius. Or a diameter if I draw it all the way across the circle. So this kind of shows that a diameter will be perpendicular to the tangent line at the point of tangency. And there's our construction for it. All right, that was fun. Nice little break with the calculators and numbers to do some constructions. What if a tangent line does not intersect a radius, but some other chord? Use the following diagram to answer each of the following. So if we have a tangent line connected to a diameter, we know the angle is going to be 90 degrees. But what if we have a tangent line connected to a chord that's not a diameter? Okay, well, why is Tn tangent to the circle? Well, Tn's tangent to the circle because it has one point of intersection. When a segment has one point of intersection with a circle, that's the textbook definition of a tangent line. What type of segment is AG? Well, AG is a segment whose endpoints are on the circle. That is the definition of a chord. What is the intercepted arc for angle TAG? Intercepted arc means the part of the circumference that is created by the endpoints of where the shape touches or meets the circle. So angle TAG meets the circle at point A and point G. Our intercepted arc will be on the interior of that angle, and it's the part of the circumference in between the 2 points. That means from A to G, that is our intercepted arc, because that is the arc created from point A to point G that is also on the interior of the angle. So it's got to be inside the angle and the arc created from where the angles touch the circle. So what is the intercepted arc for angle TAG? It's going to be major arc AG. On the flip side, What is the intercepted arc for angle NAG? Well, angle NAG intersects the circle at the same points at A and at G again, but the intercepted arc there, being on the interior of the angle, is going to be minor arc AG. Now, I told you in one of the previous lessons, I think it was lesson 3, that lesson 4, major arc uses 3 letters to describe the arc because it's more than half the circle. But if there aren't 3 points there, you can't use 3 points. We use the words major arc. And then we can use the words minor arc. So minor arc AG is inscribed or inside angle NAG. And then the major arc AG is inscribed inside angle TAG. All right, what types of angles are TAG and NAG? How do they compare to each other? Well, TAG and NAG, tag and nag, form a linear pair. TAG and NAG form a linear pair. And we all know that linear pairs have a sum of 180 degrees. What about the intercepted arcs? Well, major arc AG and then minor arc AG would add up to be the full circle, which means those 2 arcs should add up to be 360. So how does the sum of the angle measures compare to the sum of the intercepted arcs? Well, the sum of the angle measures is half the sum of the arcs. Very interesting. So if the sum of the angle measures are half the intercepted arcs, what happens if I tell you major arc AG is 200 degrees? So if I tell you major arc AG is 200 degrees, that means that minor arc AG has to be 160. That way, the 2 arcs together add up to be a full 360 degrees around the circle. What follows, major arc AG of 200 degrees divided by 2 gives us angle TAG as 100 degrees. And then the linear pair means that angle NAG would be 180 minus 100, or 80 degrees, which is also half of arc AG. So what we're seeing here is that an angle with a vertex on the circle, where the sides are created from a tangent line and a chord, the angle is half the intercepted arc. Same rule as an inscribed angle. So when the vertex is on the circle, inscribed angle has 2 sides that are chords. This particular situation is one side's a tangent, the other side's a chord, but the angle measure is still half the intercepted arc. We know that when a tangent line meets a radius, it's a 90-degree angle. Technically, you know what? Watch this. It's technically the same rule. It's just that if I extend this radius to make a diameter, that 90-degree angle is half of a 180-degree arc. It's half the circle. So it is the same rule, where an angle formed by a tangent and a chord is half the intercepted arc. So the measure of angle X is going to be half of the measure of arc Y. You got that? Okay, next. What's the difference between the locations of the angles in these 2 diagrams? These are 2 different pictures, and they're going to have 2 different sets of rules. So in figure 1, how many intercepted arcs are on the interior of the angle? The intercepted arc that's on the interior of the angle is right there, 1. If I have 2 secants that eventually meet and intersect somewhere outside of our circle, so I have the intersection point of 2 secants, there are 2 intercepted arcs there. Now, the inscribed angle is half of the intercepted arc because there's only one arc to worry about. But because there's two arcs for where our secant intersects the circle, there's two different arcs. There's a bigger one and a smaller one. We need a different rule to figure out the measure of the exterior angle. The inscribed angle is half the arc. That's simple. But this exterior angle, little bit different rule. So the exterior angle is half of the difference between the two intercepted arcs. The measure of an angle formed outside of the circle, whether it's two secants, like our first diagram is two secants that eventually meet outside the circle. The measure of that angle is half the difference of the arcs. If we have one tangent and one secant, the angle is half the difference of the arcs. Even if it's two tangents that meet outside the circle, the angle is half the difference of the intercepted arcs. So you subtract the arcs, divide by 2. So let's do some examples, shall we? Yes, we shall. Angle ACD is formed by what type of segments? Do you know? Do you know? Do you know? Well, AC is a secant because it touches twice. It slices the circle 2 times. CD is a tangent because it touches once. What is the measure of arc AD? Well, if you look at the numbers that you're given in your diagram, we know that a full 360 around the whole thing, around the whole circle is 360 degrees. So if AB is 100, BD is 85, you should be able to calculate AD. Now I ask, what's the measure of angle ACD? Well, angle ACD is an exterior angle formed by a tangent and a secant. So we are supposed to do half the difference of the intercepted arcs. So I take half the difference, means subtract, of the two intercepted arcs. Half of 90 is 45 degrees. So the measure of angle ACD outside the exterior angle is 45 degrees. All right, so let's do some more examples. Find the measure of, or the value of Z. Now, we talked about how an angle formed by a tangent and a chord, the angle is half the arc. So our 70-degree angle is half of arc Z. So to find Z, you'll just double both sides. So Z is 140. The problem we just finished said that the exterior angle is half the difference of the intercepted arcs. So if we're trying to find the exterior angle, we do half the difference of the intercepted arcs. And when you subtract, always subtract larger minus smaller, so our result is positive. Hopefully you're following along okay. We are almost done for the day. Find the measure of angle W. Oh, I'm sorry, not angle W, arc W. Find the measure of arc W. We have tangent line, tangent line. There's two different ways we can do this one. We could do it the easy way. If I know that all of the arcs around a circle have to add up to be 360 degrees, if part of it's 110, we can just do 110 subtracted from 360. Or the fun way is I know that the exterior angle is equal to half the difference of the two arcs. I could just solve for W that way. Or the fast way is just subtract from 360. Either way, we get the same value. Okay, with that example done, pause the video and solve number 5 and find the measure of x. Oh, you need a little help? All right, well, let me help you with the setup here. If we're trying to find the measure of x, the little bit of an issue could come from the fact that I don't have anything for the other side, the other arc, other side of my circle. So because we know that the whole circle is 360 degrees all the way around the whole shape, we're going to label this opposite arc here that did not have a label as 360 minus x. Because whatever arc x is equal to, whatever that red arc is equal to, the rest of it is the rest of the 360. Now with that set up, we can set our exterior angle of 35 equal to half the difference of the two arcs. Now you can solve for x. So to get rid of the 1/2, I did times 2 times 2. The opposite of dividing by 2 is multiplied times 2. So that's what I did to cancel out the 1/2. That's where the 70 comes from. That way I don't have to worry about distributing a 1/2. I'll just double the other side. Double both sides cancels out the 1/2. And then I would just subtract the 360, divide by -2, bada bing. There you go. That's what you do. Okay, so now you're off and do your problem set, and you are good to go. Enjoy your day. Sorry I couldn't be with you, but that's just the way life is sometimes. So take care of each other, be well, and I will see you and talk to you soon.